talk about water retention in the body. And students always get these terms all mixed up and they always get confused with them, but please cut through all the details and make sure you understand that the more salt the body retains, the more water the body will retain, and the less urine volume you will release. So all of these mechanisms I'm about to mention are determined to retain water in the body for several purposes. You don't want to get dehydrated, you don't want blood pressure to decrease too much, and you don't want to release too much fluid in your urine. All right, so one mechanism we use is called the countercurrent mechanism. Anytime you see the word countercurrent, you should assume that there is fluid flowing in two different opposite parallel directions. So think about the loop of Henle or nephron loop. Filtrate flows down the descending part of the loop and up the ascending part of the loop. Those two parts of the loop are right next to each other. They're parallel to each other, yet they carry counter currents. The currents are flowing down in one tube and up in the other tube. All right, so looking at the descending limb, its job is water reabsorption. So it allows water to leave the tube and go out into the peritubular capillaries to help us retain water. But why is that water leaving in the descending limb? Well, right next to the descending limb is the ascending limb, and its job is to reabsorb salts, such as sodium, potassium, and chloride ions. All of those salts will leave the ascending limb and go into the peritubular capillaries. That will help water reabsorb in the descending limb. So one limb affects the other. The ascending limb's job is to make sure that salts go out of the tube and into the peritubular capillaries, which will then ensure that water in the descending limb will leave the tube and follow those salts out into the peritubular capillaries. So one limb affects the other. We call this effect a multiplier effect because the more one limb does its job, the other limb will respond. So look at this artist illustration. Look at the descending limb. Notice that water is leaving the tube at the descending limb. The reason why water is leaving the tube at the descending limb is because the ascending limb is pumping out salts. And the saltier it gets outside the tube, the more water will leave the descending limb. So it's a multiplier effect. In other words, positive feedback. It keeps happening more and more and more in order to retain more water and avoid dehydration in the body. The vessels around the loop technically are not called peritubular capillaries. The vessels around the loop of Henle or nephron loop are just like the peritubular capillaries, only they are called the vasa recta. They're basically extensions of the peritubular capillaries, but down the nephron loop and only with juxtamedullary nephrons. So if you're talking about a cortical nephron, the nephron loop doesn't actually extend down very far and doesn't help you with water retention very much. But about 20% of your neurons are juxtamedullary nephrons. Sorry, I just said neuron, I meant nephron. About 20% of your nephrons are juxtamedullary nephrons, which means that they have a very long nephron loop that extends deep down into the medulla. And that part of the nephron loop on those particular nephrons are covered in blood vessels, capillaries called vasa recta, which are just an extension of the peritubular capillaries from up in the cortex. And the job of the vasa recta is to help us conserve water by receiving water from the descending loop and receiving salts from the ascending loop of the nephron loop. In other words, the vasa recta helps us to ensure that the countercurrent mechanism and multiplier keeps happening because it'll be the receiver of all that water and all those salts. So if you look at this artist illustration, on the left is a cortical nephron in other words, most of the nephron, is up in the cortex, and it's surrounded by blood vessels called peritubular capillaries. On the right is a juxtamedullary nephron, whose primary job is water retention, and so the most important part of a juxtamedullary nephron would be the nephron loop, which extends deep down into the renal medulla. And surrounding that nephron loop, the descending and ascending limbs are a set of blood vessels called the vasa recta. Yet another mechanism we have for water retention is called urea recycling. Some urea, which is a waste product, will intentionally be allowed to leave the collecting duct and go out into the fluids surrounding the tubules, which are just called interstitial fluids. The more urea that is around the tubules, the more water you will retain. Remember, water always follows any solutes. Whether it's sodium or potassium, or in this case, urea, water will always go towards an area of more solutes. So in this case, we're intentionally keeping a waste product called urea for the purposes of retaining enough water. At the collecting duct, we can retain even more water. Let's say we're particularly dehydrated. We can retain even more water at the collecting ducts by ensuring that there's enough osmolarity, enough solutes around the collecting ducts to ensure that water will continue to leave the collecting ducts rather than allowing that water to be peed out as urine.